another way of saying, if you feed cosine to d squared plus 1, it's gone. So think about this. If I have something, so if I have L of y equal to f, right? And if I annihilate both sides, AL equal to AF, what happens? Right. So this is a homogeneous equation. Which what? Well, in the particular case that L is constant coefficient, and if A is also a constant coefficient, I already know how to solve that. AL is just something I already have techniques to solve. For example, let me make this come to life here a little bit. If we're looking at, I don't know, d squared, well, let me start out in the prime notation. So I have y prime prime minus y equals to cosine of x, all right? Then what happens, so rewrite it as an operator, so we can think about it, d squared minus 1, acting on y equal to cosine of x, right? Maybe you guys would understand better if we had the right music. You guys just, you what's that? Oh, what, I'm sorry? No. I'm saying y prime prime minus y. We haven't annihilated it yet. It's still non-homogeneous. Now, for the annihilation. So, d squared plus 1 on both sides. D squared plus 1, d squared minus 1, d squared plus 1, cosine of x. What happens? Well, that's 0, right? And this is something we know how to solve. Yeah, it's fourth order, but we can solve this thing, right? Like this is this is d squared plus 1, d minus 1, d plus 1, right? What's the solution to that? I can write it down. It's y equals to c1 cosine x plus c2 sine x plus c3 e to the x plus c4 e to the minus x. Well, you mean that we're going to build off the stuff you did last time and then just keep doing it at stupid speed? Yes. The things you say in your mind are all true. But don't worry, I'll get sick at some point and then we'll slow down. No, I'm not going to get sick. I'm not going to get sick. I must stay well. Anyway, so do you guys agree? So we got the cosine and sine from the d squared plus 1. And this gives me the e to the x and e to the minus x. Now here's the thing. We go back to the theorem. This has lambda squared minus 1 equal to 0, so therefore lambda is plus or minus 1. That tells me the homogeneous solution to this problem, all right? The homogeneous solution here is what? So from this, I can see the homogeneous YH is c1 e to the x plus c2 e to the minus x, okay? So like the general theorem that I stated before, but now we're going to actually use, the theorem is this, guys, is the solution, general solution, to L of y equal to f has form y equals to yp, well, let's say yh plus yp. So this is the homogeneous, and this is the particular. The homogeneous piece, all right, unless we're given initial data, unless we're given additional initial data, the homogeneous piece will have constants in it that cannot be removed, for they reflect the infinite possibilities of the initial conditions, right? I didn't tell you the initial position or initial velocity here. There's going to be a doubly infinite family of solutions. I mean, that's just the nature of the beast. So YH, you know, is something like C1Y1 plus da-da-da-da plus CNYN for an nth order problem. The particular solution is a specific single solution that we're trying to find at the moment. So, logically, we found this thing, right? Part of it we don't need for the particular solution, right? For the particular solution, I only need things that aren't in the homogeneous solution. So the homogeneous solution for this problem, it's got e to the x and e to the minus x, right? I don't need those. So the particular solution is just this piece of it. So what you do then, what we do, I'll actually work out the details here for you, is we say, okay, so from this annihilator method, I can see that the form of the particular solution should be yp should be equal to something like a cosine x plus b sine x. That should work. Now, these are undetermined coefficients, which is perhaps an unfortunate terminology because the thing about the method of undetermined coefficients, all right, is actually the undetermined coefficients must be determined for it to be an answer. In contrast, these C1 and C2 up here, those stay with us. By the way, there's nothing especially significant about the order of the labeling down here. If that's bothering you, bar, 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 there. They're different. Okay, so we calculate yp prime, which is what? Minus a sine x plus b cosine x. We calculate yp prime prime. We get minus a cosine x minus b sine x, right? Can you think of a way to write that in a more lazy way? What's this say? What is this? This is minus a cosine x plus b cosine x, right? Which is it's exactly minus yp itself, right? So what does the particular solution have to do? It has to solve the differential equation. What is the differential equation? It's yp prime prime minus yp equal to what? Not 0. This is not the homogeneous solution. This is actually going to take care of this cosine. So we put that equal to cosine. And then, okay, so what is this, though? This is minus 2yp equal to cosine, right? But that's minus 2a cosine x minus 2b sine x equal to, oh, I'm an idiot. Why am I making this so complicated? Look, I've got this equation. Why don't I just solve for yp? Duh. Yp equals what? You can't always do it like this, but this time it worked, so let's do it this way. Don't worry, we'll do more examples next time of this method. So that's the particular solution. Now I can go make good on the details to the theorem I was writing over here, right? So like this is our general sort of master instruction set for all of our Legos, if such a thing existed. That would be it. Here it is, y equals to my homogeneous piece, which is what? C1, e to the x plus C2, e to the minus x, and then minus 1/2 cosine of x. And that is the general solution. Oh, good, we still have time. In the next example, I will do to music that is appropriate for the method. What? Come on. You stupid thing. Don't you mute on me. It's fine. It's not as awesome, but it'll have to do. Come on. What the what? I said, oh, why is my computer not making noise? Oh. Ah, I just thought of something. Yeah, but it's not. Ah, there we go.
That's all popped in my head too.
Now we have the appropriate music for the problem.
Well, you're getting copyrights, right?
So suppose we want to solve y prime prime plus y prime equal to x. So this is from lambda equal to 0 2 times. So I choose annihilator, d squared. So this, I get d squared plus d acting on y equal to x, multiplied by d squared. And so that's 0. And this gives me d cubed times d plus 1, which tells me that my general solution is like this. The homogeneous piece here is from this. So like I can see the homogeneous piece is going to be this piece and that piece. This is the homogeneous piece. So whatever's left has to be the particular solution. The particular solution this time I will set yp equals to ax plus bx squared. Then all I got to do is differentiate that and plug it in to determine my undetermined coefficients. Let me do that. So let's see here, yp ax plus bx squared yp prime a plus 2bx yp prime prime 2b, so yp prime prime plus yp prime. The song isn't too long. Tick tock, tick tock. 2b plus a plus 2bx equal to x. And then I solve. I equate coefficients here. So if you look at this, there's only one x term here. So therefore, there's a 1 here. This gives me 2b is equal to 1. b is 1/2. And then this has to work out to 0. So a has to be equal to minus 2b, which is minus 1. So yp is equal to, uh-oh. There's no telling what's next. There we go. Therefore, yp is, what did I just work out? Minus x plus 1/2. And so in short, the solution is y equal to c1 plus c2 e to the minus x plus 1/2. So what I'm doing right now, guys, is called the method of annihilators, but it's just motivating undetermined coefficients. This annihilating thing, after a while, we'll stop doing it once we learn how to construct the particular solution with confidence. So anyway, much more on this next time. Next time, we're just doing this, and I'll be going slower. Sorry, guys. I got started late today. My own stupid fault.